Hey everybody, I'm just going to do a little video for you here to talk about what you probably found when you did that lab simulation, and also kind of discuss the results of what you saw in the Edpuzzle video that you did. Hope you're all doing well. Um, First kind of projectiles we're going to look at in this unit are things that were just shot horizontally, meaning initially they were only going sideways. Since the Earth is always pulling downwards on the projectile, it doesn't keep going sideways, so even if this thing were shot sideways, this is just a projectile that was shot sideways at 100 meters per second. This would be like its initial horizontal velocity. It has no initial vertical velocity because it was shot sideways. And at regular time intervals, I made a motion map here. So here's where the thing would be at regular time intervals along its path. Notice that the horizontal velocity doesn't change. Now, why is that? Well, if you look at the forces acting on any object in free fall, it's only being pulled downwards. So the sideways component of the velocity never changes. What does change is the vertical component. So vertically, this thing is moving faster and faster and faster and faster at regular time intervals. So these would be horizontal velocity vectors, and these would be vertical velocity vectors. Notice only the vertical ones are changing. If we wanted to describe where this thing was at any given point in time after it was launched, we could use our familiar position function to do that, but you got to kind of treat the two components separately. So let's talk about where it is sideways first, horizontal position. This is your long and sometimes ugly looking kinematics equation, and this means where it is horizontally, where it began horizontally, what it was launched at horizontally, the initial horizontal velocity, how long it's been in the air. 1/2, this would be the horizontal acceleration, and this is time again. Well, we know that it's not accelerating horizontally, so this whole term would cancel out. We get to define where the origin is, so it would make sense to put the origin where the object begins. So this would be 0 horizontal position. That means this term cancels out. So this function actually gets really simple. X, where it is horizontally, is equal to its initial horizontal velocity times how long it's been in the air. So if you know how fast the thing was shot sideways, and you know how long it's been in the air, you just multiply those two numbers, excuse me, and it'll give you where the object is horizontally. So in this case, it was shot at 100 meters per second. This function would tell you at any given time where the thing is horizontally. As far as vertical goes, start with the same equation here, but we're going to apply it to just the vertical direction. So y is where the thing is vertically. Y initial is where the thing began vertically. Initial vertical velocity, that would be Vy naught. This thing was shot sideways, so it's not going to have any initial vertical velocity. Now, what it is going to have is vertical acceleration, and you guys know that, excuse me, any object in free fall, the acceleration is going to be -10 meters per second squared. So let's look at what this equation turns into. If we define the origin here, this would be 0 vertical position. Then we get to cancel that term. There was no initial vertical velocity because this thing was shot sideways. It wasn't moving up and down to begin with. So this actually simplifies quite a bit to say 1/2. Now the vertical acceleration is going to be -10 meters per second squared times time squared. So if I rearrange this a little bit, 1/2 of -10 is -5 meters per second squared times t squared. So if I put in any time and multiply by this and square the time, that's going to tell me vertically where the object is. So that would tell me how far down it is. So this function over here would tell me how far to the side the thing has gone. This function right here will tell me how far down it has gone. Notice you put a time in and multiply it by -5 meters per second squared, it's going to give you a negative vertical position, which is good because we defined 0 vertical position here. So it's always going to be below that vertical position of 0. This one would give you a positive number. 100 meters per second times t would always be a positive number, and that's because the origin is here, and it's always going to have a positive x value.